Very good. Yeah, thanks, Bhaskar. Thanks, everyone. And I just got to get the code up there. We're going to be going through this code in just a moment, but let's first make our introductions. Hi, I'm Michael Perry. I support a language or a library called Jinaga, and Jinaga does end-to-end state management, and it's intended for offline first web applications. So I'm really excited and pleased to have this opportunity to share it with you, to show you how Jinaga works, and hopefully you'll find a use for it in your own applications. I am a trainer and a consultant. I work for a company called Improving, and I wanted to shout out to all of the React developers out there. Hopefully you came to learn a little bit about how to do state management in React. If you want to apply those skills, we are looking for React developers right now, especially if you've got some .NET and some Java skills to go along with it. So please reach out to me for that. So we're here to talk about state management. So when we think about state management in a JavaScript application, we're thinking about keeping track of the state that's in the browser. And so you might be thinking Redux. Redux is an excellent state management library that keeps a store of all of the data that you're currently working with. And so with Redux, you've got this information that is captured as JSON objects and kept in memory on the client. But that's only part of the story. The other half of the story is the same data that lives on the server. So it might live in a SQL database, might be in MongoDB, whatever it happens to be. It's a different data store than the one that you've got on the client. And so in between, you've got some kind of API that translates your HTTP calls into statements that will update and delete and modify the data that's on the server. So when I'm talking about end-to-end state management, I'm talking about not just what's in the browser, not just what's on the client, but really everything from the client through the API to the browser. That's what I mean by end-to-end. And so I've worked on Jinaga now for 5-6 years. And I did that in order to solve a problem with state management that I saw out there, and that is that data looks different on different places, and you have to transform it into different things. But if we could kind of unify that and do this end-to-end state management, then we could have a much simpler experience. And so we I have that experience running now, and I've got some applications built on top of it, and I just really wanted to share that with you as well. So in order to get started, I'm going to extend a little bit of trust, and I want you all to go to this URL. I'm going to go ahead and paste it in the chat. Let me get the browser out over here. There we go. So I will chat this out to everyone as well. All right, so if you go to that URL, you will end up at this shared list application. So I've deployed this app to Azure, and this is an application that lets us collaborate on lists. So for example, I could have a list of villains. So I go to villains, and you can see I've already got something on the list there, Daleks. So Daleks are one of the scary recurring villains in one of my favorite shows, and so I wanted to keep a list of what villains to look out for. So if you go to shared list and you type in villains, then you'll go to the same page. You'll be able to see that list, and hey, look, somebody's watching. They were able to add that to the list. I saw that in real time. If if I add Cybermen to the list, then you'll see that pop up on your screen as well. So this is a shared application. It's a collaborative space that people can exchange information through this space. It's kept in the browser, it's kept on the server, and it's sent to other people's browsers. So this is really what I'm talking about when I'm talking about end-to-end state management. And this is what Jinaga is designed to do. So that that shared list that you see is going to be the same shared list as somebody else sees, and Jinaga is in the middle, making those things talk to one another, and it's storing that information in its own database on the server, and it also gets stored in the client. If you want to get the source code to follow along, that's at my GitHub account there, Michael L. Perry /shared list, and I'll be sure to share that out as well at the end of the talk. So let's break this down. Let's talk about how we manage data in our typical application. So typically you'll have storage that's in something like a SQL database. So you'll need to create a table. You'll need to create some schema on that storage on the server side, and then do some sort of migration so that you keep the data up to date. You keep the database up to date with the application. And then you're going to have to take these API calls where the client is sending information to the server, and you'll have to translate that into statements that operate on that SQL database. So these are the different steps that you'll typically go through as you develop your application in order to store new data. So what does data storage look like in Jinaga? In Jinaga, it looks like this. Jinaga stores data as facts. A fact is just a JSON value. I'm using the word value here to differentiate it from an object. An object you might think of as something that you have a pointer to, you can modify it, and then it's going to change state as you modify it. But these are JSON values, just like the number 3. It's the same value no matter who is looking at it. So the list that we were just looking at is this value right here, this JSON object that is the type shared list.list and the topic villains. That's it. That is the entire value. You notice it doesn't have an ID. There's no database ID. There's no external identifier. That value is the identity. That is the identifier for that list. And then we added an item to that list. And so we said that the description is $, and it was created on this particular date. And that is another value that is then saved with the system. Let's see how that plays out in code. So what I have running here, we've got our application that's running out on Azure. You can see right here, I've started an application just running locally. So I've got that at localhost 8080. If I come up here and I take a look at localhost 8080, I can go to villains, and boom, I've got the same information. And so this is an application just running locally, but it's connected to a distributor that's running out here on Azure. And so we're able to see the same information. And so I'm going to make some changes to the source code that's running locally, and then we'll be able to run that and see how that interacts with the system running in Azure. So first of all, we're going to create a fact, shared list, and the topic is villains. So that's just simply identifying this page. And then let's go ahead and add another one. So we already added Daleks and Cybermen. Oh, the silence, yeah. That's a good one. So I'm going to save that. You'll see that over here, Webpack is going to pick that up and build it. And now we've got a brand new client-side application. So when I refresh the page here, then you'll see the silence gets added to the list. So it's just run this code right here, and it has expressed this new fact that there is a new shared list item. It belongs to this list, so we've got a reference back to the previous fact here. Description is the silence, and it was created right now. So as you're building a Jinaga application, you're not going back to SQL and creating new tables. You're not creating new API endpoints. All you're doing is you're capturing these JSON values, and then that is how you store data in Jinaga. So that's the first part of end-to-end data management. So is that pretty clear? Any questions there? Nope. All right. So now let's take a look at data retrieval. So typically, you'll post some, you publish some kind of an API that people can get access to your data. So you're going to have some URL that identifies the information that you want. And then you've got a controller back there that is going to translate that into some kind of a select statement. It's going to pull the data from the database, and then the controller has to turn that into JSON. And then you finally get back to the client side. And on the client side, you're going to use some API like fetch in order to grab that information and then put it into your data store. So so here, this is using a Redux feature in order to take that information and put it into the store after it's been fetched. So again, you've got data that looks one way on the server, looks a different way on the client, and you've got this API that you have to manage in between. So what does end-to-end data management look like? In Jinaga, it looks like a specification function. Okay, this is the part you have to kind of really noodle over. It takes a little bit to get your mind around it. But a specification function is like a template. It's the shape of the data that you want to match. So here, I want to match everything that's a shared list item that is related to this list. And so I'm just giving it this specification and saying, okay, find me facts that look like this. And I want you to start from a particular list. So let me show you how that ends up in code. So here, I'll go ahead and comment this one out. And we are going to instead, now that we have our shared list with the topic villains, I want to look for items in that list. And I'm starting at that particular point. So I'm just matching anything where type is shared list item and list is that particular list. It doesn't matter what other fields are on this JSON value, they're going to match. So this is a subset of the fields that it's matching against. Okay, so we're going to run that query, and what we'll get back is an array of items. So now I want to display those items. So when I save this, let Webpack do its thing. Come on, Webpack, you can do it. There you go. And now I'm going to refresh the page. And there we go. We've got our items. So this is the result of a query. You get back just a bunch of JSON values. So each one has a type. The type is always shared list.item because that's what I told it to match against. Okay, and then the list is always the topic of villains because that's the list that I told it to start with, and I said it matches on that list. And so now this is the entire list of all of the items that are on that particular page, and they're all related to the same list object here. And so this right here is the part that kind of twists your mind a little bit, because you're used to having a parent own an array of children. Here you have an array of children, each one refers to the parent. So it's a little bit backwards from the way that you're used to thinking about it. But the reason for that is so that we can create the list first, and then we can start to create items related to that list. So the items always point back in time. They point back to their predecessor, the thing that came before. And that's why we have the parent inside of the child instead of vice versa. But that is how our data retrieval comes across in a Jinaga application. So now I'm looking at this list. This is looking pretty good. And then I want to go ahead and record another villain. This one is one of my favorite villains because they're not villains, but they are. They're very strange. The ood, they're very odd. So I went ahead and added that to the list. Now, if you take a look at this array that we got back, we don't see the ood on this array. And that kind of makes sense because we awaited j.query, and then we got back our list of items, we displayed them, and we're done. So j.query displays the, or it gets back in a list as a point in time. So this is your results at a particular moment. What you really want to be able to do is to bind those results to the user interface so that, as we've seen here, anytime there's a change, it shows up on the UI. So how do we take care of binding? Well, in your typical application, and here I'll use Redux as typical, even though Redux is far from typical. In your typical application, you will have things like you'll dispatch to the store an action that needs to take place, and then when the store follows that action, it finds a reducer that it's going to apply to transform the state. So basically, compute a new version of state from that action, and then in the client, you're going to select part of that state in order to bind to the user interface. So use selector inside of a React application will tie that update to the value of that was selected, so that if an adapter, or if a reducer puts new information in there, then you're going to apply that update again. So that's typically what we have to think through in order to bind our data to the user interface. Is we have to think kind of very mechanically. It's like, okay, this is going to be dispatched and it's going to make this reducer fire, and now I'm going to select that and I'm going to bind it here. So what I wanted to do was to take this mechanical, if this then that kind of thinking and tracing through, and replace that with something that was very declarative. And so in a Jinaga application, the way that you do binding is you create a projection. So here I've got a projection for an item. What does that projection look like? Well, I'm going to take the field, which is the item itself, in this case, I, and that's going to be item. And then I'm going to take another field that's just I.description, and that's going to be the description of my projection. And then I can just map those properties onto a component, and now I've gotten the item and the description from that projection. And so then I could just use those properties as I would in any other React application. So here I'm taking that description field, which I know to be a string, and I'm just displaying it. That item field, that's the entire item fact itself, the entire JSON value. And so I can create a new fact based on that one saying, okay, this item is now completed, and issue that as a fact. So I'm taking this projection and I'm rendering my user interface from that projection. So that's all good, but let's see that in real code. So here we are just in the main application. Let's dive a little bit further into this application. So here's our app, and I'm doing a whole bunch of React routing. So I've got my home page and my list page. List page is the interesting one. And so in here, I have a list container. And the list container is where things get really interesting. So I'm starting with a list projection. So this is a projection for a list. Oop, go away. So list is just the JSON object. It's just the JSON value. Let me go ahead and dive into list here. I'll keep that open. This is really just a TypeScript class that helps me to create list values. So I say a new list of this topic, and then it also gets that type. So shared list topic villain, that's the list that's coming in. And that's all it is, just that JSON value. So the projection for a list is the list itself, and the topic, which is a string, and then the items that are in that list. Okay, we'll get to that one in a little bit, but yeah, here's how we're just taking the list and the topic, and we're just binding it straight to this render method. So we're just going to render out the name of the topic, and that's how that gets on the screen. But then how do all of these items get on the screen? That's the cool part. So here we are binding the collection, which is j.4 items in list. j.4, that, if you recall, was how we did, or this right here. That was our specification. So that's items in list, and j.4 is how we say that we want to execute that specification. So, okay, get the items in the list, and now I want you to bind them to this item component. And then display them in ascending order by their created date. Okay, what's the item component? That is another projection. Now we're mapping the properties of that projection onto this smaller component. So we're mapping the projection for a specific item. And here we're pulling out its description and putting that inside of the checkbox. So we're nesting these projections and mapping them to other to properties of other components so that we can nest the components. So it's a very declarative way of thinking through building the application. You're not thinking about when something is added to the list, and you're not thinking about the actions and the reducers that will modify, or not modify, but compute a new version of state. Instead, you are just declaring that whatever the results of this specification function are, and there's that specification function, pretty much what we saw before. Whatever the results are, I want you to display those right here in this collection. Okay, so that's a lot to reason through. That's the part that takes people the longest to latch onto. But once you're there, once you got that, then it's kind of amazing to see things come to life and to just work. For example, you can see that these things have checkboxes next to them. So I can check, like, let's see, the silence. You know, I don't even know what the silence is. I don't remember anything about the silence. So let's go ahead and check that. And, uh-oh, something just went wrong here. All right. Let me do a refresh on that. Interesting. Okay. Oh, right. I haven't implemented anything on the onCheck. I want to remove the silence from the list when I do that. So right here inside of my checkbox, let's do something with that. I have the item, and I want to remove that item from the list. So what can I do? I can't modify a JSON value because these are immutable historical facts. These, once they're expressed, they're true. So what I can do is I can capture more JSON values. So here's one that I might capture. Well, let's do on change. And then inside of this lambda, I'm going to do a j.fact. So I'm going to capture a new value, and I'll say this one is a new completed. And completed what? Completed item. All right, so I'm going to complete that item. What does that do? This just simply creates a JSON object where the type is shared list item completed, and the item is the item that I passed in. So I created this this type to kind of help me out. There's really no reason that I have to use the type. I could just simply say, yeah, here's a new fact. Its type is that, and it's related to this item. That's all I'm really doing is I am capturing that, that JSON value as a fact. And so I'm going to do that whenever the user hits that checkbox. So let me go ahead and save that. We'll see it recompile here. There's the recompile. So now I can refresh. Now I've got the one that has the j.fact in there. And so I'll check that, and hey, it disappeared. Why is that? Why did it disappear? It disappeared because I created a shared list item completed. And if I go back up one step, is that keystroke. Right here, I am showing this collection for items in list. There's a part of this specification that I haven't talked about yet. So yeah, it's matching against the values that have this item, or I'm sorry, this type of shared list item, and related to this list, but it's also got this condition, so such that it is not completed. So what's this item is completed? Well, that's just another specification. In this case, it's using j.exists rather than j.match. And so this gives you a condition. So an item is completed if there exists a completed fact. So if somebody has gone through the trouble of creating a fact of type, completed type, that's this string right here, related to that item, then we're going to consider it to be completed. So if that exists, it's completed. Well, as it so happens, somebody did just create that, and they created that right here. Okay, so once that exists, is completed is true. And so that means that in list is not going to include that completed item. So it's such that it is not completed. Okay, so a lot to work around, a lot to think through. I know that is the that's the brain twist, but once you've got that, then things start to go pretty smooth. So do we have documentation for Jinaga to understand the specifications? Yes, in fact, we do. So let me go to jinaga.com. And if we go to docs, then there's a whole bunch of steps that will take you one step at a time through the process. Writing specifications is one of the first concepts. So storing information, just doing j.fact. Writing specifications, we've got our j.match, and we've got our such that. So these are the conditions. And then, this is something that Jan helped me out with. Thank you very much, Jan. We've got these diagrams that show how all the pieces fit together. So as you get into it, you're going to have this help to guide you along your path. Excellent question. Okay. So that is a bit to think about. Let's pause and practice that just a little bit more. Let's say that yeah, here I am on my list, and I am looking at the items that are on the list. So there's the items container that's being injected in here. So that's my collection of items. I also want to display the items that are not completed. So I want to show things that are, I'm sorry, these are the items that are not completed. I want to show the items that are completed. So let's go ahead and see if we can make that happen. So that means I'm going to want to show something here like completed items. Right, so where is that going to come from? Well, that is going to come from my my projection, because I'm mapping the properties of the projection into this component. So completed items, I want that to be something up here. All right, and now it's turned red because it doesn't know where completed items comes from. That's because it's supposed to be inside of this projection. Okay, so let's go ahead and add completed items. Okay, and so I want this to be a collection. And so I'm going to start with this list. So this is a projection for this this list. What does it mean for an item to be completed in the list? Well, as it happens, I've already got that query right here. So an item is in the completed list if it matches this template right here. So it's an item and it's in the list. And then such that the item is completed. So that's just the opposite of this one. So this is such that it's not completed, such that it is completed. So it's in the completed list if it's in the list and there is another fact, a successor to it, that is a completed item related to that item. So I'm going to use j.for item in completed list. And then I need to give it a component. So I'll call this the completed item component. And then optionally, I can have this ordered. So let me do ordered ascending. We'll start with the created date of the item, but we can probably do better. We can probably have these in order of their completion date. But let's do one thing at a time. So completed item component. I need to define that somewhere. Let's go ahead and define that. So completed item component. Oh, we've already got the completed item component. Oh, yes, that's right. Okay, so completed item components. I'm just going to, for an item, map the description, and then just display that in a div. Okay, so let's bring that in, import that. And now we're going to show all of these completed items below the list. So let me go ahead and refresh this. And now, let's see. I see Daleks and I see the silence. Okay, yeah, there we go. Yep, it took a little bit for the completions to make it to the client, so they still look like they were in the list. So yeah, we are now seeing the Daleks, the silence, and Ood added to the completed list. So now what do you think would happen if you were to check one of these off? So let's just check hello, Michael. Boom. It's removed from the items and added to the completed items. And it's put in the order in which it was initially created. So that's why it ended up right there in the middle. So just updating the information that just happens because we've declared that these projections map to properties of components. And so when new facts show up, then the projections will update the user interface. So go ahead and check one of those others off of the list, and what you'll see is that it doesn't matter if the fact comes from me or if it comes from you. So is somebody clicking on one of them? So if you go ahead and click on one, you should see it update on my screen. Yeah, there we go. Cool. So that is the power of end-to-end data management. It's that it doesn't matter if it came from my end, if it came from your end, if it's already stored on the server. It's all treated the same. You just write things as these immutable JSON values, what I call facts, and then you write declarations of the specification, how things are supposed to be displayed, and how they're supposed to map to properties. Okay. Hey, Bud's trying to enter. Awesome. Hey, Bud. Good to see you. All right. So we have gone through the hairiest bit of Jinaga. This is how you have to kind of switch your brain into a different way of thinking. But like I said, once you're there, then there's a whole lot of things that really start to unlock. So one of those things that just unlocks for you is collaboration. So typically, if you're using something like SignalR or Socket.io, what you'll do is you'll write some code on the server that detects an event, and then it sends that on a socket to the client. So this might be server-sent events, this might be WebSockets, but whatever the mechanism, it's going to send that message to the client. And then on the client, you receive that message, and then you update your user interface accordingly. So you have to know that a thing has happened on the server, and then on the client, you have to respond to it. And the way that you're responding there is a little bit different than the way that you're responding to something that the user is trying to do. And it's a little bit different than the way that you're responding to data that you're loading from the server in the first place. So it's just, you're thinking about different ways that data could get into your store. And you're doing this in a very imperative, send this message, receive this message, do this thing kind of a way, a fashion. Now, you've seen that our application is collaborative. How does that work in Jinaga? It works like this. What you do is you do a j.subscribe, and you give it You guessed it, a specification function. So I said, okay, I'm going to subscribe to this list, and what I care about is the items in this list. Now, what do you do with those items? You don't have to do anything because you've already told it what to do with those items. You've already told it how to bind those properties to components. You've already told it the specification functions for how to map those into projections. So all of that is still good. That all of that still takes place. All you have to do is set up this subscription, and then when you're done with it, you just stop the subscription, and then it stops updating. So let me show you where that comes into play. So here I've got my, let's go all the way back to the list page and kind of take this from the top down. So the list page, we can see that we're taking this parameter, that's the topic, that's a string. So that comes in here. We knew that it came in on a URL, so we're going to decode that. And that gives us our list. Now remember, that list is just a JSON value. It's just type is shared list.list, and topic is that string. So that's the value that we've got here. And so now we're just going to j.subscribe to that list for the items in the list. And that's my item subscription. Now, I've also subscribed to the completed list for that in that list. So I'm looking for items in the completed list, and then I'm looking for those completions themselves. So I'm looking for the completed for that item. That's another specification function that's just looking for items of type completed related to that item. So using this .for .then syntax, I'm able to chain them together. And just to remind you, the rules for chaining those things together are all expressed right here. So we can do the .for and the .for and .then to chain these together. So that is just subscribing to all of the completions of all the items in this list. So whenever one of those facts is expressed, whenever somebody on a completely different machine saves that fact by clicking a checkbox, then that gets up to the distributor. The distributor says, hey, you subscribed to that. Let me send it to you. And then it makes it to the client, and the client already knows what to do with it. And it just updates the user interface. So that is what collaboration looks like in Jinaga. So you can see once you get over that hump, things get a lot simpler. This is just a simple subscription. Okay, so that's collaboration. Let's talk about one other thing that gets just a lot simpler once you have unified your data management, and that is taking things offline. That was what I promised you in the title, right? So we're going to build an offline capable application. So you might have studied how to build progressive web apps, PWAs, and when you read about how to do a PWA, it answers a lot of the really hard problems, like how do you cache the HTML and the CSS that's going to be displayed on the application? How do you cache all of the JavaScript that makes up that running application? What you don't hear an awful lot about is how do you cache the data? How do you take all of the information that the user has seen, that they've downloaded into the app, and all of the data that they've generated, all of the work that they've done in the app? How do you cache that so that the next time they come back to the app, they can see it? Well, in a typical PWA application, you would use something like IndexedDB. This is a capability that's built into the browser. So first of all, you have to check to see if your browser supports it. And then you await, sorry, typo. You await the the IndexedDB, you open that collection and look for the stores within the collection. If it's not there, go ahead and create that object store, and then you can read and write against that store. So you have to write this code on your client that says, okay, I'm starting up. Let me read all the data from local storage. Let me put that into my store. And then let me make my API call, fetch data from the server if the server is available. If not, I'm just going to render what's here in the object store. Oh, somebody just made a change. I need to save it to the object store, and I need to make the API call if it's available. If it's not available, I have to queue that change. I'm going to queue that in IndexedDB, right? Because it's right here. And then I'll sync it up later. So you got a lot of code to write in order to make all that happen. So how does that look in a Jinaga application? It looks like this. You just say IndexedDB and you give it the name of a collection, and then it takes care of saving all of the facts that it has received from the server, saving all the facts that the user has generated while using the application. It saves the facts that came in from other users if they're using it collaboratively. And then when Jinaga runs any kind of a query or a projection in order to take that data and display it, it's going to first run that projection against IndexedDB, and then it's going to make the call out to the server. So the PWA launches, displays the information, the user is happy, it's all right there, and then it's making this call out to the server. If it works, then they see fresh data pop into the browser just a second later. If it doesn't, then they're still just working with the last data that they saw, and they're happy. Any changes that they make are stored within IndexedDB, and then whenever Jinaga can make that connection to the server, it will go ahead and push that data up to the server. Let me show you where all that lives inside of the shared list application. So I'm going to go ahead and open up the network tab here. And you'll see right now, if you were to try this yourself, you will not see anything under IndexedDB for this this application. So apparently I'm using localhost 8080 for other applications. So other applications have already stored information in IndexedDB, but not shared list. And that's because I haven't enabled that yet. So let me come back to this little Jinaga config up here. And this is how I'm setting up my Jinaga connection. So I'm going to say IndexedDB shared list. Okay, save that. Webpack rebuilds. Thank you, Webpack. And I refresh. And now it has created the shared list collection. Inside of this collection, we will see things like, here are all the facts. So we can see the shared list item completed, the shared list items. It's got all of the information about them. So yeah, here's the OOD created on this date. So all of that is saved in IndexedDB for you. You didn't have to write any of that code. You already told it how to save a fact. It's just saving it to a different place. You've got things like the queue. So if I were to say mark a thing completed, like no question so far, then it would, oh, well, oh, yeah, okay, it's not going to refresh the queue in real time. In order to really see this, I would have to like go to my Wi-Fi settings, and I have to, no, I'm not going to be able to run that demo. We're actually running live right now. But if I were to be offline, then anything that I do here, you would be able to see those show up in the queue. So that is how you take data offline using Jinaga. It's just a simple declaration because you've already done all the hard work. Oh, one other thing to point out here. Notice that the HTTP endpoint that I set up here, I gave it the endpoint of the Azure Websites distributor. This is the configuration that I would usually use inside of an application. This is just going back to the same distributor that the application came from. So by setting up the HTTP endpoint to be a different distributor, that's how we're able to collaborate and share information. So yeah, you can have your applications pointing to all sorts of different distributors, and they're just sharing facts one to the other, and that's how you build an application in Jinaga. Okay, so kind of a quick cheat sheet. State management, how does it work in Jinaga? Well, you've got storage, you store facts. Facts are just JSON values. You've got specifications. So your specification is a function that describes the shape of the fact that you're looking for. Then you've got projections that will take those specifications and it will project those onto fields and properties and collections. And then you can map those fields, properties, and collections into a component in order to display them. You've got subscriptions in order to do real-time collaboration. And you can take things offline by just simply declaring an IndexedDB collection. So that right there is what state management looks like in Jinaga, and it truly takes it end to end. Browser to server, from the server to another browser. So collaboratively, offline, it's all managed. So for more information, go to jinaga.com. Up there, you'll see a whole bunch of steps. So each one takes you just step by step through solving one small problem with Jinaga and getting everything set up. There you'll also find a link to a YouTube playlist that I put together of Jinaga commits. Each one is 10 minutes or less, and it just takes you through one little solution to a problem. And so they're really easy to watch and I think a lot of fun. So thank you very much. Please, any questions?
Thanks, Michael. I think there was one comment in the chat about disabling the network access through Chrome developer tools.
That is true. Yeah, but then I wouldn't be able to do my freeze joke. Yeah, that's true. So let's go ahead and try that. So we're in the application, and I think it was.
I think, Michael, it's in Network tab.
Yeah, there we go. So we will do offline. There we go. Then back to the application, and I'm going to say, let's, so we did the silence. Goodness, why am I blanking on my villains? Anyway, so one more thing. Add that to the list. We can see that shows up here. I'm going to go back to my queue, and we'll see that we've got the list and the item are in the queue. The reason that the list and the item are in the queue is because the item has a pointer to the list. So in order to understand the item, it has to know what the list is. So it's not going to assume that the server already knows the list. It says, okay, here are the new facts that you need to know about. So they're in the queue. And then we go back to network. We go online. And then after a little while, we will see these disappear from the queue. So the network is going to be doing some retries here. Eventually, we'll see that it says save, and and then they will leave the queue. Yep, there they go. Yeah, thank you for that. I hadn't thought to use that feature.
So I have a quick question, Michael. First of all, thank you for your talk. I was wondering if you have any plan to support other server types other than Node?
Mm-hmm. Yes. Yeah, in fact, Jan and I have started thinking about what does Jinaga look like in .NET. So yeah, not only do we want to support other server types, we also want to support other client types. So yeah, I would love to see a Jinaga.net that works in Xamarin and in Blazor. That's still a ways away, but it's open source, and I'm really excited to be able to work with you if you want to help out.
Absolutely, actually, I would love to be part of that. We are mostly Microsoft shop, so that would be great, especially with Blazor. So thank you so much.
Yeah, thank you.
Michael, you wrote a book about this.
I did.
How can people catch up? How can they know more about it? What if they want to use Jinaga?
Yeah, so the book in question is The Art of Immutable Architecture. So this is a book about the mathematics behind what you saw here. So it's all about modeling your data as a series of immutable facts, really a graph of immutable facts that are all related to one another. So that's where these JSON values come from. So to learn more about that book, go to immutablearchitecture.com. And there you can also find a link to a book study that we do once a week on Discord. And that's a great way to get connected with the project and help us out.
Awesome, Mike. Thanks for showing the demo and giving us an overview about Jinaga. So if someone is coming from a Redux world or an NGRX world, right? So do you see it will be easier for them to transition to consider Jinaga?
If they're coming from Redux, I think that there are some concepts that they're going to have to kind of unlearn. So like we talked about, we don't have reducers, we don't have actions. And so there is kind of a learning curve no matter where you're coming from. RxJS, I would say that kind of reactive thinking is a different declarative way of thinking about data management. So now you're thinking in terms of creating pipelines and having streams of information go through the pipelines. So Jinaga doesn't use that concept. It instead is focusing on these specifications and the projections. Really the background that I think would give you the best leg up would be if you have some experience with functional programming. So you're thinking in terms of an immutable data set, and then you're running functions on them in order to project them into other shapes.
Thanks, Michael.
Yeah, thank you. This has been a pleasure.